Welcome to the team, and welcome to btg-devops. This is your handover walkthrough. By the end, you'll understand exactly what this tool does, the 12 things it scans for, what's already built, and where to start on day one. There's no live session to catch. Everything you need is right here. Let's get into it. So what is btg-devops? It's a command line tool, written in Go, that scans Microsoft Azure subscriptions for security misconfigurations, cost waste, and best practice violations. It authenticates using an Azure Service Principal, that's a non-human identity, with read-only reader access, so it can safely inspect an environment without ever changing it. Under the hood, it's built on Go 1.21, the Cobra command line framework, and the Azure SDK for Go. Credentials come from 4 environment variables: tenant ID, client secret, and subscription ID. In short, pointed at a subscription, and it tells you what's wrong. The tool is organized into 12 analysis modules, each a subcommand under Analyze. Let's walk the first 6. App Service Traffic looks at your web app traffic patterns. The IAM module inspects role assignments. Who can do what? Storage checks your storage accounts for exposure and misconfiguration. Network Security Groups, or NSGs, are your virtual firewalls, and that module flags risky rules. ACR covers your Azure container registries, and Cosmos DB checks your managed databases. Each one runs with a simple command like btg-devops analyze IAM. Here are the other 6. Key vaults, where secrets and keys live, get checked for safe configuration. Azure Functions covers your serverless code. Public IP addresses flags anything unnecessarily exposed to the internet. App Service Plans looks at your hosting tiers, which is often where cost waste hides. Cognitive Services, also called Azure AI, covers your AI resources. And Resource Groups gives you a top-level view of how everything is organized. 12 modules, one consistent pattern. Using it is straightforward. You run btg-devops analyze, followed by the module name. A few global flags shape the run. Subscription ID to target a specific subscription, resource group to narrow the scope, and output to choose your format. A human-readable table by default, or JSON for piping into other tools. And every single finding, no matter which module produced it, has the same 4 fields: a severity, a category, a description of the problem, and a recommendation for fixing it. Severity is one of 3 levels: critical, warning, or info. That consistency is what makes the output easy to work with. Let's be clear about where things stand. The good news: all 12 modules are implemented and working. There are cross-platform release binaries built automatically for macOS, Linux, and Windows, on both Intel and ARM. The README covers all 12 commands, and the docs folder has a spec for each module. The main branch is clean. Now the gaps, because they define your job. There is no continuous integration workflow. Nothing automatically builds and checks the code. There are no unit tests at all. There's no version file or changelog. And there's a guide for connecting to an external system over MCP that was written but never actually wired up. The features are done. The engineering rigor is not. That's where you come in. Your first deliverable is continuous integration. Add a GitHub Actions workflow that, on every push to main and every pull request, builds the whole project, runs the tests, and runs the linter. On every version tag, it should build those cross-platform binaries automatically. There's a catch knowing up front. The test step will fail until tests actually exist, so adding tests is a prerequisite for CI going green. Get the pipeline scaffolded, then make it pass. That brings us to tests, the second deliverable. Create a tests directory with table-driven tests for each module. Table-driven just means one test function running many input and expected output cases. Focus your coverage on three things: that the output format is correct, both the table headers and the JSON schema, that the severity classification logic is right, meaning the thresholds for critical, warning, and info, and that edge cases are handled, empty resource lists, nil values, and malformed responses from Azure. Those are where bugs hide. Third, tidy up releases and documentation. Add a changelog, either auto-generated from your commit messages or maintained by hand. Tag releases using semantic versioning, moving from version 0.12 to 0.13 and onward. On documentation, the docs folder already has a feature index and a doc per module, so your job is mainly to verify they still match what the code does after you make changes, and to add a contributing guide with the build, test, and lint instructions, so the next developer ramps up fast. Looking ahead, the plan is to extend scanning beyond Azure, with each new target following the exact same module pattern. 4 are on the roadmap: Hetzner Cloud, scanning servers, volumes, firewalls, and load balancers, using a Hetzner API token. Microsoft Power Platform, Power Apps, Power Automate Flows, Power BI, and data loss prevention policies. Microsoft License Compliance, finding unused seats and over-provisioned licenses, which is real money. And M365 Security Posture, conditional access policies, multi-factor authentication status, and Defender. Read through the Microsoft Graph API. Same interface, new surfaces. Beyond more targets, the tool should get smarter about when and how it reports. The goal is to move from on-demand scans to scheduled ones, a schedule flag, or an external cron job, running the analyzer on a regular cadence per subscription. It should produce delta reports, what's new and what's been resolved since the last run, which means storing a little state in SQLite or JSON file. And critically, findings should be routed into keyflow-MCP as the canonical destination, where each finding becomes a tracked entity with its severity, category, target, description, recommendation, and the run it came from. Here's the long-term vision, so you understand where your work is heading. btg-devops becomes a single, normalized scanner across both cloud and software as a service. One command analyze, followed by any target, regardless of the provider underneath. There's a provider-agnostic internal schema for findings, with provider-specific adapters translating into it. Everything flows through Keyflow as the single source of truth, and the web interface becomes a viewer, not a place where data is written. The thing that makes this valuable isn't the number of checks. It's that normalization layer that makes every provider look the same. A practical note on permissions, because you'll hit this on day one. For all 12 modules, the Service Principal only needs the reader role on the target subscription, read-only, nothing destructive. 2 modules need a little extra. App Service Traffic also needs access to Azure Monitor metrics, since it reads traffic data. And the Key Vault module needs GT permissions on secrets and keys to inspect them. Everything else is plain reader. Least privilege by design. A few conventions to internalize. Build before you commit, run go build. Test before you push, run go test across all packages. Lint your code with the linter, Golang lint. Output defaults to the table format, with JSON available when you need it. The subscription comes from the Azure subscription ID, the environment variable, unless you override it with a flag. Every finding carries those 4 fields: severity, category, description, recommendation, and severity is always critical, warning, or info. Follow these and your work will feel consistent with everything already here. So, your first week in priority order. First, there's no continuous integration. Adding the GitHub Actions workflow is the very first thing to fix. Second, there are no tests. Start with the IAM module, since it has the most complex logic, and work outward from there. Third, remember the release cadence is manual. You tag a version and push, and that triggers the binary builds. Fourth, the MCP integration is documented but not wired up, so the operator may ask you to connect it to keyflow staging. And finally, keep this in mind for confidence. All 12 modules are production-ready with no known bugs. Your focus is engineering quality, tests and CI, not new features. Welcome aboard and let's ship.